Hi everyone, I just wanted to take a moment to talk about conjectures and go over a little bit of practice to show you how you can come up with some. So as a quick reminder, conjecture comes from inductive reasoning, and really all it is that we're doing is we're looking at a pattern, um, or we're looking at information that we're given, and then making a statement that we haven't proven, all right? So by that I just mean we're kind of essentially predicting what's going to happen. However, we don't have any formal method at this point of saying that's definitely what's going to happen. So if we look at this one, for example, we start off with 4 dots in this little pattern, and 6, 8, 10. So if you were to make a conjecture in regards to the next item in the sequence, you would probably make this prediction that it's going to be this, right? 5, 5, and then 2 on the top, the 1 on the top of the bottom. We don't know. For all we know, it could start going back down. It could just stop doing that in general. But this is ultimately a way that we can make our conjecture in regards to what the next item in the sequence is going to be. You would need some sort of justification for it. You can't just say, well, it's going to be that because I thought so. Well, that doesn't really help me because that doesn't show that you're using any of the information you have. Ultimately, you are basing this off of what you already know. So it should be related to what you know already, all right? Now, for something like this, you could set up a pattern to figure out what would be the nth term, right? If this is the first term, second term, third term, fourth term, fifth term. What if I wanted the 60th term or something like that? And it still follows this pattern, but I had to draw it all out. Is there any way I can do it out? Well, we know that in this first one here, we start off with 1, 2, 3, 4. And then this middle one here, the second term, so 1, 2, we have 2, 2, then 1, 2. So just by the fact that we have the 1, the 1, the 2, and the 2, kind of gives me the idea that we want, 2 times my number of, or the term number it is, and then plus the top and the bottom every time, so plus 2. So I could figure out every single time roughly what my nth term would be based on this formula, right? If I wanted the 60th term, it'd be 2 times 60, which is 120, plus 2, 122, would be that many dots. All right, alternatively, you could get something like this one, which is a little bit more numeric, where every time all you're doing is you're multiplying by negative 1/2. So at this point, you'd go to the next one, multiply by 1/16, or something like that. Now, in regards to how you could do this with geometric, so obviously up here is a little bit easier because we had a sequence, right? So we had a lot of information. Now we just need to say anything potentially related to the information we're given, right? So we could say, we're just making any sort of conjecture. We're making our prediction based on the information we have. Angle ABC is a right angle. Okay. Maybe we could say triangle ABC is right. Okay, like I am using the information I have because ABC would be an angle of this triangle, and that would make it a right triangle. We don't know. I can't prove that this is part of a right triangle, but it's within the realm of possibilities. You could do something else too. I don't know. Maybe you could say it's one of the vertices of a square. It's within reason. Over here, point S is between R and T. So, well, what can we say about that? You can say that they're collinear. Though we kind of already knew that. Because, well, it doesn't say it. It doesn't say it. You could say something like RS is equal to TS. I mean, we don't know if it's the midpoint, but you could. You could just say that RS plus TS is equal to RT. And ultimately, I think that kind of exhausts most of our possibilities on that one. But you could do something like that based on the information you're given. Similarly, with this one, you could say, well, they're a square. Or on this one, you could give me some information maybe about the side lengths or something like that. Okay? All right, so let's move on and talk about how to prove conjectures false. We cannot say a conjecture is true using any of the methods that we know yet. Well, we can say it's supported. So I don't even like the wording on this. Supported. We don't prove conjectures at this point. Well, you can prove conjectures. At this point, we haven't done anything to know how to prove them. So we're not directly saying that they are true at this point. We're just supporting them. All right. So how can you support them? You can show more examples where that is actually true. And you don't have a way to show that's not true. So on this one, for example, STU are collinear and ST is equal to TU. All right. Then T is the midpoint of SU. So I could draw a couple different lines, S, U, and then at the T, because these have to be the same, right? You could draw a couple examples like that. Maybe now it's a little bigger, S, U, T, because they are collinear. And we're also given the information that ST and TU are the same. Okay, so you can try and see if you can come up with a counterexample. However, you're not going to directly come up with one as far as I can directly see. Okay, on this one, angle 1 and angle 2 are adjacent angles, then angle 1 and angle 2 form a linear pair. Okay, well, there's a pretty obvious counterexample here. 1, 2. Those are adjacent. They're not a linear pair. So this right here, this is a counterexample. All right, I'm still starting with my piece of information at the beginning, right? I'm still starting with 1 and 2 are adjacent. That part we're starting with, because if I had started with 2 non-adjacent angles, that doesn't even apply to the situation, right? It'd be like you were dealing with, baseball, and then somebody said the greatest basketball player of all time, and you just didn't be like, well, that has nothing to do with what we're talking about. But anyway, so this would be a counter example. Or, for example, you could make an argument. Let's say if you didn't like my lovely sports reference, you could maybe do something like in regards to baking, talking about making the best chocolate cake. And then somebody says the best way to make cookies is to, combine the butter and sugar first. I mean, yes, it is. You should do that if you're baking cookies. But that doesn't apply to the situation about cakes, right? It's just not, it's not involved. So you do need to start with the appropriate piece up here. The 1 and 2 are adjacent. So, and then we have a counterexample, and then as such, we can go, gone. That's not a valid conjecture. It has been disproven. All right. So finally, let's look at this last one. GH and JK form a right angle and intersect at P. Okay. So these are segments. GH and JK form a right angle, and they intersect at P. Okay. Well, this one's a little bit tricky because it seems like there's a lot more points than are necessary on this one. But anyway, you could kind of come up with different configurations, right? You could do something like that, or that's pretty much about every point you're going to get out of there. But ultimately, if they're intersecting and forming a right angle, I guess you're saying that they're technically perpendicular, right? Because perpendicular, what is the definition of that? There's that they meet at right angles. So Yeah. But anyway, the big one to take away from this is number 10 here. Okay, so if you have any particular questions about conjectures, please let me know. Have a great day.